In this video, I will be introducing a new concept or arrangement of conics called harmonic notes. There are fifth harmonic notes, fourth harmonic notes, and third harmonic notes. Let's start with the fifth harmonic for a brief description. If we refer back to the fifth harmonic we discussed earlier, once we found a correct length for the conical radius for the fifth harmonic, we were able to draw 12 conics and identify the 12 vertices of the icosahedron. From there, we were able to identify the 20 face axes as well as the 30 edge axes. These axes will be the basis for the fifth harmonic notes, which I'll get to a little bit later. Let's refer back to the fourth harmonic, which we saw in an earlier video, which defined the 6 vertices of the octahedron. This also allowed us to locate the face and edges as well. These axes will be the basis for the fourth harmonic note. Referring back to the third harmonic that we saw in a previous video, it allowed us to locate the 4 vertices of the tetrahedron. From there, we were able to locate the edge axes and face axes as well. The third harmonic notes will be based on these axes. There are various harmonic notes that will be discussed in this video. So let me describe the nomenclature that will be used to classify the various harmonic notes. H represents the harmonic, 3, 4, 5. I represents the interval and which axis the conics is centered on. The upper N indicates how much smaller the radius is than the base note. The lower N indicates how much larger the conical radius is for the base note. And the A represents which axis is intersected by the conics. I'll be using the fourth harmonic as an example to describe in detail how the various fourth harmonic notes are constructed. The 4V note is an arrangement of 6 conics centered around the vertices of an octahedron. There are 3 different 4V notes described here, and let's start with the 4V base note, where its conical radius is the distance between adjacent vertices. The 4V base note is identical to that of the fourth harmonic we discovered earlier, where its conical radius was used to divide its conics into 4 equal arc segments, which guided us to locating the 6 vertices of the octahedron. The 4V upper 1F note uses a smaller conical radius than the base note, and it intersects the next closest face axis. Let me show you how it's constructed. There are several other fourth harmonic V notes, and they are basically identified by smaller conics that would intersect with the face axis. And now I'm going to be drawing additional conics, sized by the adjacent face axis. And now I can draw 6 more circles, all based on these new conic sizes. So this is another fourth harmonic V note. The 4V upper 2E note uses an even smaller conical radius than that of the base note, and it intersects with the edge axis. Now let's look at how it's constructed. And there are other conics with slightly smaller circles where the conical radius is determined by the distance between vertices and the edge. The fourth harmonic V note, the conical radius defined here with an edge axis. Here's one circle. And that's another fourth harmonic V note. The next class of fourth harmonic notes are the 4F notes, which are an arrangement of 8 conics centered around the face axes of the octahedron. There are 4 different 4F notes listed here. And I'll start with the 4F base note, where its conical radius is the length between adjacent vertices of the octahedron. Let me illustrate its construction. So we're going back to this fourth harmonic. And now introduce another type of conics, where the conics are centered at the face axis of the octahedron. And the base note for the 4F note is set to intersect another face axis. I'll show that a little bit later. So this is the base note for the fourth harmonic B note, and it's going to be set here for another face axis. The 4F upper 1V note uses a smaller conical radius than the base note and intersects with the next closest vertex of the octahedron. Let me show you how to construct it. There's another conic length that will intersect the vertices. Alright, so this is the next note. And the RTA is going to hit an axis vertices. The 4F upper 2E note uses a smaller conical radius as well and intersects with the next closest edge axis of the octahedron. Let me illustrate its construction. There's a third one that intersects with the edge axis. This time the conical radius is defined by the edge axis here. The 4F lower 1E note uses a larger conical radius than the base note and intersects with the next furthest axis, which is the edge axis of the octahedron. Let's look at how it's constructed. And yet another one where it's actually longer than the base and intersects another edge axis to make another conical length, and I'll show you these in more detail. And notice how this 4F note is identical to a spherical cube octahedron. The next class of fourth harmonic notes are the 4E notes, which are an arrangement of 12 conics centered around the edge axis of the octahedron. There are 4 different 4E notes listed here. And we'll start with the 4E bass note, where its conical radius is the length between adjacent edges of the octahedron. Let me illustrate its construction. Now we're going to look at the E note, where conical radius is set to adjacent edges. Alright, so let's try out the whole note. The 4E upper 1V note uses a smaller conical radius than the bass note and intersects with the next closest vertex of the octahedron. Let me show you how it's constructed. The next one over intersect with the vertices. The 4E upper 2F note uses a smaller conical radius as well and intersects with the next closest face axis of the octahedron. Let me illustrate its construction. An even smaller one would go to a face. The 4E lower 1V note uses a larger conical radius than the bass note and intersects with the next furthest axis, which is a vertex of the octahedron. Let's look at how it's constructed. And then the larger one go to basically an edge like that. This table illustrates the various 4V notes, 4F notes, and 4E notes that we just saw. Now let's move on and take a look at the fifth harmonic notes. There are 3 classes of fifth harmonic notes: the 5V note, the 5F note, and the 5E note, and are constructed in a similar way as to those in the fourth harmonic. I will briefly describe these fifth harmonic notes here, as I will explore these in greater depth in a following video. There are 6 5V notes that use conical radius defined by the distance between the vertex of an icosahedron and its various axes. Here are some illustrations of what they look like once they're constructed. There are 8 5F notes that use conical radius defined by the distance between the face axis of an icosahedron and its various axes. Here are some illustrations of what they look like once they're constructed. There are 9 5E notes that use conical radius defined by the distance between the edge axis of an icosahedron and its various axes. Here are some illustrations of what they look like once they're constructed. Table 2 lists all of the fifth harmonic notes and also lists them in descending order of the length of its conical radius. In the following video, we will look at the various ratios between all of these harmonic notes.